Hi everyone, welcome to the hands-on part of the Getting Started with KORTEX API video. The goal of these hands-on sessions is to take what we've learned after looking at the examples project from the Kinova GitHub repository and try to apply it to our own application. Over the course of the next videos, as we learn more about how to use the KORTEX API, we will build upon what we're starting today and try to make our own visual servoing application for pick and place. So let's begin. As you can see, before we started the video, I already created a few files, namely an empty script named full example, as well as a class named KORTEX robot. However, you can see that the implementation for this class is still not done. This is what we're going to do together today, as well as filling the example. Before we start the implementation, let's look at what's going to be into our class. First, the KORTEX robot will need a constructor and a destructor, of course. Then we will make a function to initialize the API and connect to the robot, more methods to subscribe and unsubscribe to notifications, as well as callbacks for errors and notifications. As you can see, our class already has a few attributes, namely a string containing the IP address of the robot, a boolean noting if the robot is connected to the API or not, and a vector of notification handles that will tell us the list of topics that we are subscribed to. We also have all these pointers that are the pointers we're already familiar with, so the TCP client, the router client, session manager, the device config client, as well as the base client. Before we start with the exercise, let me explain you my notation. M underscore simply states that this variable here is a member of a class. Then the first letter, in this case S, indicates that it's a string, while B is for boolean and P is for pointer. Now that we're all set on, let's start with our implementation. Okay, so for our implementation, let's first start by generating definitions for all of those methods. So we can generate a definition for a constructor, another one for a destructor, for the initialization method, for the subscribe method, the unsubscribe method, and so on and so forth. So let me do this quickly. On error. Finally, on notification. Okay, so now we have all generated our definitions. Let's fill them in. First, since we're going to initialize the entire API in this init function, all we need to do in the constructor is actually load the IP address. So we can register the IP address in the member named MSIP and leave it as is. That's it for a constructor. For a destructor, what we need to do is replicate what we did in our example on getting started. Right at the end here, we need to replicate all this, but only if the robot is connected to the API. So how do we do this? First, we can check if the robot is connected. Is connected. Then, if the robot is connected, it means that we have to disconnect the session manager. We need to deactivate the router client. And we need to disconnect the transport client. Now that everything is disconnected, we can destroy all the pointers. The base, we can delete the device config, session manager, delete the router client, and finally delete the TCP client. That's it for the structure. Now it's time to initialize the API. Again, we can look back to our getting started example and see how we initialized everything. Basically, we need to replicate all this, except we're going to use the class members that we have already initialized. So first, let's just make a dummy error callback for our asynchronous function. So we have auto error callback as a lambda function, API error, and then we can just print the content of this error. ToString. So this way, whenever there's a callback for an error with an asynchronous function, we will print the content of the error. Now we need to make a new TCP client. So TCP client is a new Kinova API transport client TCP. We need a new router client. So MP router client is a new Kinova API router client that will connect to our transport and use our error callback. Now let's see if we can connect. So if we are not connected, to this IP address, and since we are connecting to the TCP client, we use port 10,000. If the connection fails, then we can print an error using cout, failed to connect. And line. And return false. This way, whenever we call the initialization function, if the initialization function fails, we will know about it. Then we will try to connect to everything. So let's use try, because in case we catch an error, we will be able to catch a Kinova API detailed exception. We will implement the catch function once we're there. So now we can try to connect to everything. So first we need a new session manager. So it's a new Kinova API session manager that will connect to our router client. Then we need to create a new session info. This variable is temporary, which is why we can dump it once we're connected, which is why we don't save it into our class. So it's Kinova API session and create session info. Let's fill them with the default password and username. So create session info dot set username to admin and create session info dot set password is also admin. Then we can set the session inactivity and connection inactivity timeouts. Just like we did in the example, we can do create session info dot set session inactivity timeout. Let's use 60 seconds or 6,000 milliseconds. And create session info set connection inactivity timeout, and now let's use 2 seconds or 2,000 milliseconds. Finally, we can use our session manager to create a session using these information. Now, assuming everything went well there, this means that we are connected to the robot. Now we will need to access devices. So first we can have a new device config client. So it's a new Kinova API device config, device config client. That's connecting to our router client. And finally, we need base. MP base is a new Kinova API base client connected to our router. Now let's assume something went wrong and we catch an error. Then what we will want to do is use this methods on error callback that we will implement later. Otherwise, it means everything went well, we want to return true. That's it for initializing the robot. Now let's subscribe to the topics we're interested in. But first, how do we determine what topics are interesting? We can look into the documentation that's available on the GitHub that we can see on our GitHub page on the API documentation markdown summary pages notification topics. Here we can see that to subscribe to any notification, what you need to do is select the service you're interested in, use the function onNotification and the name of the topic, and with a callback and notification options. Here is the list of all the available notification topics that we can be interested in. For this example, we can use the action topic. So action topic means that now that we're back into our function, we need to subscribe only if we're connected. So first we have if the robot is not connected, if the robot is not connected, we do nothing. However, if the robot is connected, then we will need to create options. So options are in the API common section, notification options, and leave those empty. Then we can just select the type, set type, and our notification type here will be a notification type event. It's in common notification type event. And there you go. Now, to be able to map the callback used for the notification to the method, we will need to use the std bind functions from C++. And for convenience, we will also use the placeholder namespace. So we'll do using namespace std placeholders. With this, we can then make an std function that is Kinova API base action notification as an attribute. Let's call this our action callback. And this function will be binded to our onAction notification method. So we use std bind, a reference to our KORTEX robot onAction notification callback. For this, and use a placeholder for 1 to pass a parameter. Now that we've created the function callback, we can subscribe using a handle and the base client. So what we want to subscribe, as we've seen on the GitHub page, is now on notification action topic. So for this, we want to pass the action callback as well as our notification options. Now, in order to be able to unsubscribe from this, we need to remember this handle. So what we will do is take the notification handle list and push back the handle. That's it for subscribing to topics. Now it's time to unsubscribe. Let's pretend that we've subscribed to more than one topic. Then the first thing we need to check is, first we need to check if we are connected. So as usual, if the robot is not connected, we do nothing. Otherwise, we can loop through all the handles in the notification handle list. So to do this, we can do for auto handle from the notification handle list and use a base client to unsubscribe from this handle. And that's it. This way, no matter how many topics we subscribe to in our subscription function, this will unsubscribe us from everything. Now let's do our error callback. If you remember, we used our error callback in our initialization function, but we can use it on many other places whenever we try and catch a Kinova function. So we've used it here. So now that we've caught our exception, we can do just like in the previous example. Here, we can take what we put into error detail and then redo it inside of our function callback. So since all we are doing in this function does not rely on any of the attributes inside of our class, what we can simply do is take everything, copy, and then paste here. Let's change this placeholder for Kinova API everywhere. Finally, Kinova API. And we're done with our error callbacks. This way, whenever we get an error, we print the entire detail, and we are aware of our problems and we can try to fix them. Finally, for our action notification callback, this can only be called whenever we're connected. This is the same for on error callback, so we do not need to check whether or not the robot is connected. For the moment, let's simply print that we've received a notification. We will implement something more complex in a future video once we're aware of the content of actions. So let's go fill in our example. First, we need to make a KORTEX robot that we'll call robot by calling our constructor. I enter my IP address, which is 192.168.110, which, as a reminder, is the default IP address of your robot if you're using the default Ethernet port. Then we can connect to the API with our initialization function. If we are connected, then first we can give ourselves a message telling us that our connection was successful. STD and line. Then we can subscribe to notifications. And here, this is where in future videos we will insert our new code. This is where we will start our application, but since the goal for today's demonstration was only to connect to the API and subscribe and unsubscribe to notifications, I will simply add a note here to do stuff later. Finally, I can unsubscribe to notifications, and we're done. We can give ourselves just a hint here telling us that this is the end of the example. And that's it. We don't have to call the destructor of our object because as the main script will finish, it will call the destructor by itself. So now all we have to do is build. As you're building either this project or any other one from the examples repository, you will notice that there are many warnings. This is normal. So our build is successful. Let's run our example. As you can see, our connection was successful, we were subscribed, and then we can end the example. That's it for today's hands-on session. I hope you enjoyed it. Join me in my next video where we will learn finally how to move our robots using the KORTEX API. Have a nice day. Thank you for watching.